Hey guys, welcome back to a new video, and in this video we're going to start a new series of learning Kotlin Coroutine for absolute beginner. If you are absolute beginner in Kotlin Coroutine, then this video is for you. I will try to cover everything which is right now is used in most of the companies, and if you want to create any Android application by yourself, then Kotlin Coroutine is the most important thing to know, because without asynchronous programming you are not going to create any Android app. So let's get started with our video and try to understand what are the approaches we have previously and what are the benefits we'll receive when we'll use Kotlin Coroutine in our project. Let's get started. So first we'll try to understand how our Android operating system will work. So Android is a Linux based operating system, and in Linux we have processes. So all of your applications that you are seeing right now in your mobile device are nothing but a process, and when you click any of the icon it will eventually start a new process. So in order to execute tasks in our process, we'll have threads. We have multiple threads and sometimes we have single thread. It depends on the use case. So if you want to execute 10-20 tasks at the same time, then for that we'll have to create 10-20 different threads within our process. So threads are resource expensive because it need memory, and also it requires some of your CPU usage. When you create a lot of threads, you will have to assign a lot of memory, and also every threads will need CPU usage. So let's try to understand this thing with a very simple analogy, a restaurant analogy. Suppose I'm a restaurant owner and I want to run my restaurant. For the time being, I have only one chef. One chef means only one thread. Now one customer come to my restaurant. My chef goes to the customer, take his order, come back to the kitchen, prepare the meal and deliver it. So it's a very simple flow. Now what will happen if 20 customer come at once to my restaurant? Because I'm having only one chef, so my chef goes to the customer one, take his order, come back to the kitchen, prepare the meal and deliver it. And after the first customer delivery is done, then it goes to the second customer, similarly goes for the third, fourth, fifth. When our chef reaches to the 20th customer, surely it will take a lot of time, and this is the problem with single thread. So to encounter this problem in our restaurant, what I'll do, I'll hire more chef. More chef means more threads. So when we have a lot of chefs, surely I have to pay more to my chefs. That means we have to allocate a lot of memory, and also we'll have to give a space, a kitchen space where they can work, right? In Android, we have to allocate all of these thread, some memory and also some CPU usage. And this is a problem. If you will create a lot of thread, surely it will reduce the performance, because every thread will require memory and some place to work or some CPU usage. Okay, so now I'm gonna elaborate all of this thing with code in my project. So you have to create a new project, Android project. It's a very easy thing. You can do it by yourself. Now in this, let's say I have a main function, okay? And in this main function, for the first scenario, I have only one chef which will manage everything. So every chef has three responsibility. First, it will take order, mention the customer name, and it will simply print the message that order have been taken for customer one. Similarly, we have to cook the food for my customer first. So I'm gonna again use here println and print the message food is cooked for my customer. And solely if you cook food, it will take a little time. So for that, in order to simulate that behavior, I'm gonna use here thread.sleep. So my thread will sleep for 4 seconds, and if my thread sleeps for the 4 seconds, it will not do any other task. That means it goes into the sleep position or sleep mode, and once we're done with it, we'll have to deliver it. We will connect all of this analogy with coroutine though. So just try to understand the use case of thread, the problem with threads. Why do we actually need coroutine? Okay, so once we're done cooking, we'll deliver it to customer name. So every chef has three responsibility: take the order, cook the food, deliver it. Now I'm gonna first take the order for customer one, then cook food for customer one, and lastly deliver it to my customer one. So this is for the single chef. As you can see, order taken, food is cooking, it's done, and after that we'll have delivery. Okay, so let's say I have two customer. So for that, again the procedure is same, just change the customer 1 to customer 2. So once our safe will finish with the first customer, then only it will take order from the second customer. So execute it. As you can see, right now it is preparing food for the one. It's done, and after that it will take order from the customer 2, preparing order for the customer 2, and then deliver it. Right? Now, as I told you, I have hired more chef. More chefs means more thread in my process. So let's replicate it. So now I have created a thread. This thread is representing a chef. So for customer 1, I have assigned the chef 1. For customer 2, I have assigned the second chef. So start will eventually start the thread execution. Okay, so now when you click on run button, parallelly it will take order from customer 1, and at the same time it will take order from the customer 2. Execute it. There you go, for 1 and for 2. And food preparation is also start for 2 and 1 at the same time. So if you have more chef, the task will be completed very fast. But as I told you, with threads we have problem. Threads need memory and also some CPU usage. With respect to a restaurant analogy, every chef will need kitchen to work, and also he wants salary. Salary means memory. So this is the problem with thread. If you create more threads, you have to assign more memory, and also at the same time you have to also assign some CPU usage to your thread. Now let's see how we can resolve all of my issues in the restaurant using KOTLIN Coroutine. Now what I can do, I can remove all of my chef and only hire one chef, and corresponding to this chef I have hired one waiter. Responsibility of waiter is to get to the customer, take his order, come back to the kitchen, create a ticket and assign it to the chef. Let's say I have two customers. So chef says to the waiter, go to the first customer, take his order and create a ticket, assign it to me. Once it is done, chef again says to the waiter, go to the second customer and repeat the thing. So now we have two different tickets. Let's say customer 1 want pasta and customer 2 want something else which I don't care. So for pasta we have to boil pasta. Surely it will take some time. Now our chef will put pasta on boil, and he will never wait for pasta to boil. Instead of that, he can switch their task from customer 1 meal to customer 2 meal and start preparing the customer 2 meal. So by doing it, our chef will never block. He never wait for the pasta to boil. He simply switch their task, and this is a very optimal way of using your resources. Now similarly, the same thing happens under the hood with KOTLIN Coroutine. KOTLIN Coroutine will suspend the execution if it will take a lot of time, and once the task is completed, then it can resume the task. This is the same thing which I am doing right now with the chef. Once my pasta is boiled, then I can simply go to the first customer meal and start preparing the first customer meal. Same thing happened with the KOTLIN Coroutine. Now let's see with code what I am talking about in here. So chef means thread. That means we have only one thread. Now only one thread can handle a lot of tasks at the same time. So what we'll do, we'll simply optimize the way of doing things. That's all. We never create any new thread. We'll not create any other things. We can simply optimize our order of execution, and that's it. And this is what KOTLIN Coroutine will do under the hood. It will simply organize your task in such a manner so that only one thread is capable of performing a lot of tasks. That means a single thread may have 10, 20, 30 or sometimes 100 coroutines. This will surely optimize your performance, and that is why KOTLIN Coroutine is so popular, because as I told you, thread requires memory and also it requires some CPU usage. But with KOTLIN Coroutine, it is not the case, because we are just optimizing the way of doing things. That's all. We are not creating any threads. We are not creating any other stuff. We are just optimizing the way of doing my task. Now let's see code what we were discussing for my restaurant. So for that, in this particular example, we're gonna use KOTLIN Coroutine. So to do that, just use here return type and run blocking. So what is run blocking? We'll discuss later. Basically, all of the things that you will see in here is something which is related to KOTLIN Coroutine that we'll discuss later. So first thing first, I'm gonna just use here suspend keyword. All of my function will have suspend keyword in front of them. So why do we need suspend function? So right now our Ceph has ability to pause some execution and switch to another task. So in Kotlin Coroutine you can do this thing only when your function is suspended function. So that's the reason why I'm using in here suspend keyword in front of my functions. Now we're gonna launch a new coroutine, basically launch two new coroutine, and cut this thing out, paste in here. Similarly for the second coroutine, I'm gonna cut this thing out and paste in here. Instead of using a thread sleep, if you are using a thread sleep, it will surely block your thread, so it will give you the same results that we were having when we were using threads. Now instead of using thread or sleep, we'll use here delay of 4 seconds. Okay, so just remove it, and when you execute it, you can see this block and this block will be executed parallelly. See, at the same time our waiter will take the order and create a ticket to my Ceph, and at the end will deliver the meal to my customers. So this is what Kotlin Coroutine is. So Kotlin Coroutine will never create new things under the hood. It is actually used to properly utilize, properly structuralize your operation. That's all. All of the tasks will be executed by your thread, but all of the tasks will be managed properly by your coroutine. This is what Kotlin Coroutine is, and also we will call Kotlin Coroutine as a lightweight thread. And this thread is also called lightweight processes. So threads are like hiring many Ceph. You have to give more amount of money, and also you have to manage them properly, which is very hard. While with Coroutine, your one Ceph can handle a lot of tasks by using smart scheduling. In this video, we want to discuss about Coroutine. What is Coroutine and what are the advantages do we have when we use Kotlin Coroutine? We will discuss in this video. Let's get started. So first, I'm going to create here main function, and I will try to elaborate you all the things with practical example. So we have two more function. We have first function and we have second function, and in this main I'm gonna simply call it first and second. So when you create any process or launching an application in your Android operating system, under the hood it will create something what we call main routine. It is a core part of every program because it's where you set up and run all of your other components in your code. Because our main function is an entry point to our program, this will eventually become a part of our main routine. So I'm gonna just mention it in here. So this is a part of our main routine, and in this main function we do have two functions. Basically we are calling two functions. So it will also use a new routine. So for the first we have a different routine, for the second we have a different routine. This is our function, main function, that contains two function call, first and second. So our Android operating system will create a programming call stack, and in that call stack it will simply insert all of the function calls that we will make during our program, or you can say function execution. So just like this we have a stack, and in this stack first we will insert the main function, because main function is the part of our main routine. So it will insert main in our call stack, or you can say programming call stack. Next it will insert the first function call, and once the execution of first function call is done, it will simply remove it, or you can say pop this thing from our programming call stack. After that we will insert the second function call in our programming call stack, and once the execution of second function is done, then it will simply remove it from the programming call stack, as you can see in here. And lastly, when it removes the main function, that means our stack is empty. That means the program execution is successfully completed. So this is how a routine will work. Once the execution of first function is done, then only it will trigger the second function. This is what we call blocking invocation. Let me just show you. So I'm using here print ln and use here first, then use here print ln, and we use second. Now when you execute it, you will see the first and second. Subroutine is used to invoke a blocking call. But with Kotlin coroutine, it is not the case. You can use non-blocking execution using coroutine. Now let's see how we can do this thing. So for that, I'm going to show you another example so that for you it's very easy to understand. So let's say I'm using here our infinite loop, and in this infinite loop, I'm going to use this println function and paste in here. And on top of our while, I'm going to create a variable first, and initial value is 10. And I will increment it one by one. So first plus plus. Just copy this thing, paste in your second function, cut this thing from here and change this thing from first to second, and similarly change this thing from first to second, and it will start from 0. So we have two functions, right? First function and second function. And now when I execute it, you will never see this second print statement. This is because, as I told you, in our stack, first we have main, then we have first. So when the execution of first is completed, then only we will execute the second function. So this is the problem, and that is why you are not able to see here the second print statement, because it will never reach up to this place. So this is a problem with subroutine. Well, with coroutine, you can simply make this blocking invocation into a non-blocking invocation. So let's see how we can do this. So for the time being, when you open the console, you will never see the second print statement. First, let me just stop the process. And now I'm going to use here coroutine. So first, let me just change the type of our main function from nothing to unit. And I'm using here a run blocking. We will discuss about run blocking, launch, and everything that you will see in here. But for the time being, just be with me. Now, instead of launching a subroutine, I'm going to use here coroutine. So this is my first coroutine, and this is my second coroutine. In our first launch, I'm using first. In our second coroutine, I'm using here second. And I'm going to use here suspend keyword in front of my functions. And also I want to produce some delay for 2 seconds in our second, for 1 second in our first function. And now this time when you execute this function, you will see first second, then we have second, first second, means it is executing parallelly. Your first function, your second function is executing parallelly. This is possible only because your coroutine is a non-blocking invocation. It will execute your first function and second function in a non-blocking way. That is why your thread is free. Due to that reason, you can execute these two functions parallelly. This is a plus point of having Kotlin coroutine. The main difference between subroutine and coroutine is subroutine is used to invoke a blocking call, while coroutine is used to execute or invoke a non-blocking call. This is a difference. I think you got the advantage of using Kotlin coroutine instead of a subroutine. Well, just comment this thing out. I forgot to comment. Simply comment it and re-execute it. You will see 10, 0, 1, 1, 12, 13. So basically it is executing parallelly, and this is a plus point of having Kotlin coroutine. In this video, we're going to talk about Kotlin coroutine suspendable function, the most important thing to know. So without wasting any time, let's get started. We will discuss about the internals of suspendable function, and also we'll see how it actually execute our tasks. Let's get started. So first, I'm going to show you very simple example using thread, and after that we eventually come to our suspendable function or suspend modifier. So for that, let me create a file, and the file name is thread file. It's a normal file, and I'm gonna use a data class naming user. So for that, let me just create user data class for you, and in this we have a user ID, type is string, and we have the username. So it's a very simple data class. Now come back to our thread file, and in this I'm gonna create a function, a get user info. I'm gonna pass my user ID, and return type of this function is user. So I just want to mimic a network request call because we are using here threads. I'm gonna sleep my thread, not this, I'm gonna sleep my thread for let's say 3 seconds, and after that I'm gonna return my user. So simply pass your user ID and the name. So name is my name. So it's a very simple function that mimics a network request call which takes 3 seconds to complete its execution. Now I'm using here main function, and in this main I'm using println get user info, pass the user ID which is let's say 1. Now I'm going to show you the decompile code for this function. So for that, go to the tools, Kotlin, so Kotlin bytecode, and simply click on this decompile. So when you see the decompile code, you will see this is our function get user info, and we are passing user ID. So it check for the non-null parameter, and after that it will sleep our thread for 3 seconds, and eventually it will return me my user. But there are few problem with it, because this will sleep our thread for 3 seconds. Let's say I'm executing this function on my main thread, so my main thread sleeps for 3 seconds, and the core purpose, the core thing that our main thread will do is to update our user interface. And if our main thread get blocked for 3 seconds, eventually it will give me a crash, application not responding. So to encounter this issue, let me just first execute this thing for you. As you can see, it will take 3 seconds to complete, and after that we'll receive the user information. Now how we can actually modify this function so that our main thread does not block? So to do that, I'm going to create one more function, get user info, and this time I'm using here callback. So previously we are actually returning a user, but this time we can do the same thing using callbacks. So for that, first we have to pass the user ID. Next we have to pass a lambda. So I'm going to call this lambda on complete, and in this will return user. Now we can create a new thread, and in this new thread I'm going to sleep for 3 seconds. Now this time it will never block your main thread, because we are creating a new thread, so it's a different thread. So after sleep of 3 seconds, I'm using here on complete and simply return my user, or you can say just pass this user in my on complete function. So that's it. This is our execution. Now instead of using here get user info, I'm gonna use my get user info callback, pass my user ID which is 1, and in this trailing lambda we are getting the user. So simply use your println and print your user. Just make comment this thing. So now when you execute it, your main thread wouldn't block because of this new thread creation. So after 3 seconds you will receive the information regarding to your user. But there are few problems in it, and the problem is, let's say during your network communication you will receive some error. So it will throw an error, let's say IO exception. So you have to catch this exception, and you want to show this information to our user in the user interface. So if you want to do that thing, you have to change few things in your on complete lambda. But before that, let me just show you the decompile code. So for that, again go to your tools, Kotlin, so Kotlin bytecode, decompile it, and you will see this is our execution of function get user info callback. This is our decompile code. Now in this we are passing the function 1, because we are only passing one parameter in our lambda. That is why it will create an object of type function 1 on complete. It will check few non-null parameter things, and after that it will create a new thread, and in this new thread we have a new function get user info callback. When you control click on it, this is the actual location where all of our logic is present. So our thread will sleep for 3 seconds. Then after the completion of this line, it will use on complete and invoke it, pass my user information, which will receive in our main function. Now we want to handle the error case too. If networks throw any kind of IO exception, we want to catch it, or any kind of exception we want to catch it. So for that, you can simply make this user nullable, and also we'll have to pass a throwable. Now I'm using here try catch the exception, and if we got any exception, I'm using here on complete. In place of user we'll receive null, and in place of throwable we receive the exception, so simply pass that exception. In this try I'm using on complete, pass my user, and in place of throwable I'm using here null. So now this time on complete callback is able to handle the error case and success case both. So go back to your get user info callback, and first parameter is a user and second parameter is your exception. So when user is not null, that means we are receiving the user information from the backend, and if our exception is not null, that means we are encountering some error. Just cut your user, paste in here, and if you receive any kind of exception, you can simply print the localized message. Now just run it and you will get the information, right? So long story short, this on complete is the core part of our get info callback, because using on complete will retrieve the user information and also will receive the exceptions, right? So this is how you can actually do the things with threads. Let me just show you the decompile code so that for you it's very easy to understand. Decompile it, scroll down, and this time, as you can see, because our lambda contains 2 parameters, it will eventually create an object of function type 2. This is the creation of our new thread, and this is the location where all of our logic will be present. So thread sleep for 3 seconds. Now this time it will use try catch. So on complete invoke, pass the user information, and if you encounter any kind of exception, we'll use on complete and invoke this function, pass the exception. So it's a very simple flow. Now I'm gonna do the same thing using suspend modifier. So for that, let me just open the project mode, and here I'm gonna create one more file, and the file name is suspend file. Create a file. In this I'm gonna create a function, get user info, pass the user ID, type of this thing is string. Make sure to use your suspend modifier because it's a suspendable function, and I'm gonna use this name get user info 2 because we have already created get user info. That's why it will collide with get user info that we have previously created. Now in this I'm using delay, because if you are using suspend we can use delay instead of thread.sleep, and I'm gonna sleep this thing for 3 seconds, and after that I'm gonna return my user. So user, pass the user ID and the name and return it. Just change the type from nothing to user. We have main function, and in this main function I'm gonna use get user info 2. But before that, let me just show you the decompile code. This is very interesting part. So for that, go to tools, Kotlin. So Kotlin bytecode, decompile it, and there we go. It's a very small function, but look at the decompile code. It's way bigger than the previous one that we were having with threads. Long story short, I'm gonna just tell you what is happening under the hood. So this is our public static final get user info 2 function, and as you can see, because we are using a suspend modifier in front of our function, it passes a non-null continuation naming object naming completion. Now this continuation is a very interesting thing, because every function that you are having in your project internally uses this continuation. Now this continuation contains the information about your programming call stack. I mean, from where you'll call this get user info 2 function, because once we completed with the execution of our get user info 2 function, we have to return back to our program call stack and notify him that my execution is done, you can continue with the other functions. This continuation contains all of the information that you want after the execution of our get user info to continue with your program call stack. It contains the information about your parameter. It contains the information about your variable that you have in your function. So basically it contains everything. Now with our get user info 2, let me just show you the function. So this is our function. Now delay is another suspend function. So let me just show you the delay function, and this is my delay function. As you can see, it is also a suspend function. So for every suspend function we have a new continuation, and that new continuation contains all of the information regarding the originating call within our programming call stack. Now let's take a very simple example of this function. So imagine a call stack. In that call stack, first it will insert get user info to call. After that, it will insert delay. Now delay will have a different continuation, and your get user info have main continuation. So your delay continuation contains the information about the previous main continuation, and also it contains the information of your originating call. Now I'm gonna call this get user info to function within our main. So for that I'm using run blocking and get user info to pass my user ID, which is 4 in this case. Now let's understand this thing with programming call stack. So in our programming call stack, first we'll insert our main function, and this main function will have a continuation naming main continuation. I'm just giving the name so that for you it's very easy to understand. So we have main continuation, and that main continuation is a part of our main function. Because get user info 2 is a suspendable function, and every suspendable function will have a new continuation. Due to that reason, in our programming call stack, we will simply insert get user info, and this contains a new continuation naming user continuation. And this user continuation contains the information about the originating call within our programming call stack. It also contains the information about the line number, and it also contains the information about the previous continuation, which is main continuation. Okay, next line is delay. Now delay is another suspendable function. That means it also creates a new continuation, and I'm gonna call that continuation as delay continuation. Delay continuation contains the information about the previous continuation, and also it contains the information about the line number or line of our program, and it also contains the information about the parameters, like in this case we have 3 seconds. Next line is return user ID Himanshu. So this is not a suspendable function. That means it won't insert in our programming call stack. So now in our programming call stack we have 4 things. So we have main function, we have get user info 2, we have delay. Now these 3 will have different continuations. So once we are done with delay, we'll eventually pop this thing from our call stack and we'll return back to our get user info. And when get user info is completed, then we'll return the user, and eventually it will pop up that get user info to function call from our stack. And lastly we have main function, and when we are done with the main function, it will eventually pop that thing from our stack. So our stack is empty. That means our program execution is done. And this is how suspendable function will work. Every suspendable function will create a new continuation, and this new continuation contains a lot of information that you want after the execution of your suspendable function. Now if I introduce few more delay, let's say I introduce here 5 seconds, I introduce delay of let's say 7 seconds. So every function is a suspendable function. That means every function will create a new continuation. Well, continuation is not a new concept. It's a very old concept. Every program, every function that you have in your project or in your Android application will have continuation internally. As I said to you, it contains all of the information regarding your programming call stack. That is why it was used previously. Now with suspend modifier, because we want to suspend their execution, and when we are done with our execution, we have to return back in our programming call stack, and this information will only present in our continuation, and that is why we will create a new continuation every time when we will use suspendable function. So now we are going to discuss about coroutine builders. Coroutine builder is used to create coroutines. We have 2 different types of coroutine builders. We have standalone coroutine builders and we have scoped coroutine builder. So first we will discuss about standalone coroutine builders, and in this we have 3 types: run blocking, launch, and async await. So let's begin our journey with run blocking. So for that I'm going to create a main function, and just below to it I'm going to create a suspendable function naming get user information, and we will pass the user ID and delay. Return type is string. Basically it will return you the same user ID that you have been passing in this function. Now I'm using delay. Just insert the delay that you are receiving. Now this is a function, so simply import it and make sure it is coming from kotlinx.coroutines, and at the end you can simply return the incoming user ID. So this is my suspendable function. Now in this main I am using println and I will call it start. Next I am using println and call this end, and in between I am using run blocking. Well, let's say you want to execute this get user info function here. Well, it is not possible. Even though you have passed the user ID and the delay, still it is not possible because suspendable function is only executable either in a new suspendable function or within any Coroutine scope. Well, with main we are not having suspendable function, and also it will never provide you any kind of Coroutine scope, and that's the reason we are not able to execute get user info function in here. So for that we have to build a Coroutine scope. So for that we'll use run blocking. If you just control click on it, you can see we have Coroutine context. By the way, for time being, just understand this Coroutine context as it contains the information about a coroutine. Next parameter is nothing but a lambda, which is suspendable extension over Coroutine scope. Because it's an extension over Coroutine scope, that's the reason why in our main activity run blocking pair of parentheses, we can very easily execute get user info function and simply pass the first delay of 1 second, and we'll simply store the result in the first and print it. Similarly, we have one more second get user info second delay of 2 seconds, and at the end I am simply printing the second user info. Cool. So if you're talking about the execution of this main function, well, your thread will first print the start and after that it goes to this function. Well, run blocking will eventually block the execution of your thread. Once all of the operation that you have been mentioned in this lambda is completed, then only it will release your thread, and after that it will print the end. Now let's execute it to see whether it is the case or not. Well, we have see the start, then we have first, then we have second, and at the end we have end. So yes, run blocking will simply block your thread until and unless all of the operation that you have been mentioned in this scope has not completed. It will never release your thread, and once it is done, it will simply release your thread, and after that your thread is free to do the next line execution. So run blocking is mostly used with unit testing, or sometimes we'll use run blocking to learn these Coroutine stuffs, and we saw this thing in our previous videos. So now it's time to talk about launch Coroutine builder. So first I'm gonna remove this run blocking, and if you want to use launch Coroutine builder to create a new coroutine, so launch is nothing but an extension function over coroutine scope. That means without coroutine scope you can't use launch coroutine builder. So for that, first let me just change the return type from nothing to unit, and we'll use run blocking. So run blocking provide you a coroutine scope. Now in this we are able to use launch. So first let's see its definition. Control click on it. So this is the definition of launch. As you can see, it's an extension over coroutine scope, and in this as a parameter we have coroutine context, coroutine start, and lastly we have a trailing lambda, which is a suspendable extension function over coroutine scope. Well, coroutine context will contain all of the information about your coroutine. Later we will discuss about it. Next we have coroutine start. So it will decide the initial behavior of your coroutine. Next we have a block that we will use in here. In this launch we have a lambda. So this lambda is nothing but an extension over coroutine scope, which is a suspendable function. Come back to the builder start common, and a return type of this launch is a job. So job is an interface. It extends or uses coroutine context.element. Later videos we'll discuss about job very briefly because it's the most important thing in coroutine. Just for time being, just understand job as a normal job. And if you see the implementation, so first it will create a new code in context, and next it will check if your start is lazy, it uses lazy standalone coroutine, otherwise it uses standalone coroutine, and at the end it will simply start the coroutine and return a job to you. Nice. Come back to our main activity. It's time to use it. So launch coroutine builder is usually used when you are not interested in the result. Let's say you want to insert something into your local database. Now in this scenario, you are not interested in the result. So launch will follow fire and forgot mechanism. It's simply fire and forgot. So database insertion is something like that. You can simply just execute insert function, and after that you will forget it and you believe that insertion have been successfully done. Cool. So in this launch, if you use get user info and pass the user ID first, delay of 4 seconds and execute it. So start and end, process completed. Well, if you want to see the first user information, what you can do, you can simply create a variable and just below to it you can use first. And now when you execute it, so start end after 4 seconds, you can see the first. Cool. So launch coroutine builder is actually used when you are not interested in the result. You want to perform any operation without caring about the result, then you can use launch coroutine builder. Now let's say you are interested in the result, so for that we'll use async await. So let's discuss about async await. Now we are going to talk about async await. If you are interested in the result, you can use async await. So usage is pretty much same. You can use here async. So first let's see its implementation. So this is our async function. It's an extension over coroutine scope. So this is the most important thing that you should consider. After that we have coroutine context. We have this coroutine start, and by default its value is coroutine start dot default. And lastly we have block. It's a suspendable extension function, and it will return you deferred type. Deferred under the hood uses job, and it has variance out. That means deferred is only used to output something. Come back to builders.common, and in this it simply created a new coroutine context. It checks if it is lazy, it will create a new coroutine using lazy deferred coroutine, otherwise it uses deferred coroutine, and at the end it will return deferred type. Well, this is their implementation. Now come back to our main activity, and in this I'm simply using my get user info function first, delay of 4 seconds, and store the result in our first variable and simply print it. Now when you execute it, so start deferred coroutine, status is active, and we have some hash, and at the end we have end. Now if you are interested in the result, on that case you can simply use await. Just control click on this await. Await is a part of our deferred interface. We have await, we have on await, and lastly we have get completed. So we'll see get completed, but first let's see await. Come back to our main activity and run the main function. Start, after 4 seconds you will see first and end. Right. Now what will happen if I remove this await from here? So under the hood it start executing get user information function, and once it get back the result, it store that result internally, and when you use await it will simply provide you the result. So when you are using async, under the hood it will start executing your function that you have been used within your async coroutine scope. It's not like that. Until and unless you are using await, it won't call your suspendable function. It is not the case. Surely once your program is executed, all of the things that you have been mentioned in this async coroutine scope will start executing, and once it get back the result, it store that result internally. You can use that result either using await or get completed. Now it's time to see the difference between await and get completed. So let's say I'm using here get completed and execute it. Now we are getting problem. It says this job has not completed yet. Well, it's true, because after 4 seconds it will provide you some result. With get completed, you can simply try to find the result which is not in there. So what await will do, await will wait for some time, and once the execution is done of your get user information function, then only it will try to get the value from your default object. But with get completed it is not the case. It directly try to find the value. It doesn't matter for him whether you are getting back the result from the REST API or get user information or not. So this is the main difference between get completed and await. Now let's see. Okay, so I'm gonna use here delay. Let's say 5 seconds, which is greater than 4. Now this time when I execute, because get user information will take 4 seconds to complete, that means yes, we do have some information in a form of default which is present internally, or you can say which is stored internally by our system or this async. Now we have start. After 4 seconds we'll receive the value, and just after 1 second we'll get the result. Now this time our function will not throw any kind of exception because our job has been completed properly. Now if I reduce this 5 to 3, it will throw an exception because this execution is not completed yet. You can see in here. So this is the main difference between get completed and await. Now it is a very good time to discuss about this parameter or this Coroutine start. It's a very integral part of our Coroutine builders. So for that, what I can do, I can create few packages. Like we have start, and in this I'm gonna create a file for default one. It's a normal file, and in this file I'm gonna use main function, and in this main I'm using run blocking because I want to use their launch, and launch is an extension of our Coroutine scope, so I want a Coroutine scope in here. Now in this I'm using a launch, and I'll just try to change my Coroutine start. So if you check the function, we have Coroutine start dot default, and we have few more enumeration. We have default, lazy, atomic, undispatched. So let's use the default one first, which is by default used by our Coroutine builders. So we have Coroutine start dot default, and in this I want to print the first. After that I want to introduce delay of 5 seconds, and at the end I'm simply printing here end. Okay, so we have to just mention here the return type, which is unit. Now when you execute it, so what it will do, it will simply start the execution of your launch Coroutine builder instantly. Just run this, and you can see first after 5 seconds we'll see the end. Good. So it's a default behavior. When you are using Coroutine start dot default, this is the behavior that will have. Now we are going to talk about Coroutine start lazy. So for that I'm gonna use the returning job. So lazy, when you open this launch function, as you can see, if your start is lazy, it will uses lazy standalone coroutine. So the main difference between them is, if you are using your default, your Coroutine execution start immediately, but with lazy it is not the case. You have to manually start your coroutine. So now if I execute it, you will see nothing. This is because this time this launch uses Coroutine start lazy. I mean the lazy standalone coroutine. So if you want to execute it, what you can do, you can simply use job.start, and now when you execute it, you will see the first, and after 5 seconds you will see the end. Now what will happen if you are using async instead of this launch? Now on that case, instead of using a start, you can use await. Rest of the thing is pretty much same. So that's it for our Coroutine start dot lazy enumeration. Next we have Atomic. Well, Atomic is an experimental Coroutine API. Come back to our default file. Now with Atomic, your coroutine execution start immediately, but you are not able to cancel this execution until and unless you will reach the first suspension point. Suspension point means a suspendable function. Now in our launch lambda, we have one suspended function delay. As you can see, delay is a suspendable function, right? Come back to our default. Now let's say I'm using job.cancel, and instead of using here Atomic, use default one. Now check the behavior. Well, your job is cancelled and process is executed successfully, but you are not seeing first and end. With Atomic, it is not the case. As I said to you, it will start your coroutine execution immediately, but once it reaches the first suspended execution, then only you are able to cancel it. So logically, if I'm using here Atomic, my first suspension point is delay. That means we have to show this first. Just execute the main function. As you can see, we have the first, and after that we are able to cancel our job. So this is what Atomic enumeration is. And lastly, we have undispatched. Well, the undispatched start your coroutine execution immediately, but after the first suspension, it will change the thread that you have been passing in your launch within a parameter of your coroutine context. So let me show you. So initially I'm using here thread dot current thread name, and in the end I'm using again the thread current thread and its name. Now just remove this job.cancel and execute this function. Well, first is executing on the main thread after 5 seconds. End is also executed on the main thread. That means if you are not passing your coroutine context dispatcher, what it will do, it will use the same thread. It doesn't matter whether you are hitting your first suspension point or not. Now I'm gonna pass the context. So in coroutine context, I'm gonna use here dispatcher.io. Well, dispatcher is actually used to change the thread. So if I'm passing here dispatcher.io, that means I want to execute my operation on thread IO. Okay, so just execute it. So logically, if I'm passing here dispatcher.io, my first and end, this will use my IO thread, and this will also use my IO thread. Now when I execute it, so first uses the main, and after that it uses default dispatcher, but previously it was using main thread. So this is what undispatched is. So undispatched start your coroutine execution immediately, but with the first suspension it will change the thread, and that thread is coming in a form of dispatcher.io that you have been passing in a form of coroutine context to your launch. So that's it for our coroutine start enumeration types. So these are the 4 different types that we have in coroutine start. We are going to discuss about coroutine scoped builders. Well, scoped builder has 2 different type of scoped builder. We have coroutine scope, we have supervisor scope. Let's see one by one what is the main difference between them, and when should you use coroutine scope coroutine builder, and when you should use supervisor scope coroutine builder. So for that, I'm gonna create a main function, which I already did, and we have a run blocking. So this will provide me a coroutine scope, and coroutine scope supervisor scope is an extension function over coroutine scope. So let's begin with coroutine scope scoped builder. So for that, I'm gonna create a coroutine scope. Well, it's a scoped builder. Now in this, let's say I'm launching here a new coroutine, and in this I'm gonna print first. Again, I'm gonna launch one more new coroutine, and I'm printing here second. Now when you execute it, you will see first and second. Now just copy this Coroutine scope builder, paste below, and instead of using here Coroutine scope, use supervisor scope, and I'm gonna just use this thing in a form of prefix to this statements. Okay, just execute it. So we have first, second, we have supervisor scope first and supervisor scope second. No difference, it's pretty much same. Now the main difference between them is to ability to handle those exceptions. Well, if any exception you will throw within your Coroutine scope, it will stops the execution of their children's. Well, this launch and this launch will eventually called as a children to our Coroutine scope. Now let's say in between them I'm using here launch, and this time I'm interested to throw an exception, some gibberish exception. When you execute it, you will see we'll receive the first from this coroutine, and after that we'll receive the exception, and this is my message, which is correct. Now I'm gonna just remove or comment this thing out and use one more launch, and this time I'm gonna throw an exception within our supervisor scope, some gibberish of course. Now this time when I execute it, you will see first, second. So this is coming from our first Coroutine scope scoped builder. Next we have supervisor scope scoped builder. It will print supervisor scope first, which you can see over here. Next we'll throw an exception. So this is my exception message, and after that still it prints the third coroutine print statement, which is supervisor scope second, as you can see in here. So the main difference between Coroutine scope and supervisor scope is once you throw any exception within your Coroutine scope, it simply stops the execution of your child coroutine. Whereas with supervisor scope, it is not the case. Even though you'll throw an exception, still it continues working to their second children. So basically it continue working on the next children, and this is the main difference between them, the ability to handle the exceptions when you throw any of them within their scope. And next we are going to talk about coroutine context. So what is coroutine context? Well, coroutine context is nothing but it's a collection of few coroutine elements that contains the information regarding your coroutine. So we have dispatcher, we have job, we have coroutine exception handler. So these three collection will eventually become your coroutine context because it will give you the clear idea about your coroutine. So let's build it. So first we have to create a dispatcher. Well, dispatcher will eventually tell you on which thread your coroutine will be executed. So let's say I want to execute my coroutine on IO thread. So that's why I'm using here dispatcher IO. Next, if you want to create a new job, you can simply use here job object, just import it. So this will create a new job for your coroutine, and also it will provide you all the information regarding your job. As we have already seen in launch, the return type of this extension function is job. This will give you all the information regarding this particular coroutine. So you can create a new job and you can simply pass this job in a form of coroutine context to your launch. Next we have exception handler. So if you encounter any exception within your launch coroutine, you can handle those exceptions within this exception handler. So you can use coroutine exception handler, and in this we have two things. First we'll receive the context and exception. Nice. So it's time to use all of these three coroutine elements. So for that I'm gonna create one more variable naming coroutine context, and you can use plus operator with these three coroutine elements. Like with dispatcher we have a new job plus exception handler. So in this exception handler I'm using println and just print the message that will receive when user throw any kind of exception within our launch coroutine. Now I'm gonna use my context and pass my coroutine context in it, and in this launch I'm gonna throw an exception, and in place of message just some gibberish. Cool. So when you execute it, you will see nothing because launch is not able to handle exceptions. So in order to handle exceptions, we'll use coordinate scope or supervisor scope, and we have already discussed what is the difference between them. It is related to the exception handling mechanism. So now I'm gonna just use here coroutine scope, cut this thing, paste within this scope and execute it. Okay, so we are not receiving any kind of exception. This is because it is present within a new job. So when you remove this job, then only you are able to see the exception. As you can see in here, we are getting the exception and this is my message. But I want to print this message within this println function. It is possible when you are using supervisor scope, because with coroutine scope, once it got any exception, it simply close or shut down the operation. But with supervisor scope, it is not the case. So let's use here supervisor scope and execute it. Now this time you can see this is my exception message. So this is coroutine context, and also we have seen supervisor scope and coroutine scoped coroutine builder. Now we are going to discuss one of the most important coroutine context element, which is dispatchers. Dispatcher is used to switch between threads. It is very handy and it is a most important concept of our KOTLIN coroutine. So now we have different types of dispatchers. We have 4 different types of dispatchers, in which we have dispatchers.main, dispatchers.io, dispatcher default, and lastly we have dispatchers.unconfined, and these are having their own merit and demerits. We will discuss it very briefly in this video. So for that, I'm gonna have this very basic main function. It is already created by me. So first, let's discuss the different types of dispatchers. So as I told you, we have 4 different types of dispatcher, and these dispatchers have separate roles and responsibility. Let's say you want to do your UI updation. You have certain logic, and after performing those logic, you want to update your user interface. Now user interface, something which is only touchable by your main thread. You cannot update your user interface via any background thread or IO thread. You can only use main thread to update your user interface. Now let's understand this thing, a very simple scenario. Let's say you want to fetch information from your network or backend APIs. Once you get back the APIs, because those API will surely take some time to complete, and if you delegate this task to your main thread, surely your application will respond. Your application is not responding because your main thread is blocked, and responsibility of main thread is to continuously update your user interface after certain fixed period of interval. So what you can do, you can perform that operation on a separate thread, and once you get back the result, you can simply switch between the threads, use main thread and update your user interface. Now this is handy and this will never crash your application. So let's see how we can do this. So I have this very basic main function. I'm using a run blocking just to create a new coroutine scope, and I'm launching a new coroutine in it. I'm using here println and call this first, and after that I want to show you the thread name. So thread, current thread name. So this will print you the thread name that this coroutine was using. So execute it. You can see this is using main thread. So by default, when you use any launch or any async coroutine builder to build a coroutine, eventually it will execute on main thread. Now let's say I want to change the thread from main to any background thread. So as I told you, we have dispatcher. Dispatcher is a coroutine context element. That means you can pass this dispatcher in place of your context, and launch will have a coroutine context. So in this place, you can very easily pass your dispatchers. So now I want to use the context, and in this context I want to pass my dispatchers. We have 4 different types of dispatcher, as we have already discussed. We have default, IO, confined and main. So main thread is used when you want to update your user interface, so you can go with main. Next we have IO. So IO is very good if you want to perform any kind of network request, or you want to update your local database, or do some kind of operation which is somehow related to local database. So IO is well optimized for that use case. Next we have default. Default is used when you want to perform a very huge, very heavy computation. Let's say you want to perform audio transformation, you want to perform video transformation, you want to do something which is related to video processing. So this surely take a lot of CPU. Now this operation you can delegate to your dispatcher.default. And lastly we have unconfined. So unconfined is unconfined. If you use unconfined, by default it will start calling your coroutine on the thread that is used by you to call this particular coroutine. And once it reaches on the first suspension point, after that it will switch the thread. So let's discuss one by one all of these dispatchers. So let's say I'm using here IO, and now when I execute it, you will see we are getting something else, dispatcher default worker 1. Now I want to use here default. So again this will use some background thread instead of main, as you can see in here. Now I want to use here unconfined. So as I told you, unconfined uses by default main thread because it is executed on main thread. That's why I'm getting here main. Now the interesting part of unconfined is, let's say I'm using here delay of 1 second. Now delay is a suspendable function. That means this will become my first suspension point. And after that, when I print my thread name, you will see some difference. And the difference is it start using some worker thread, background worker thread. Okay, so execute it. First main, and this time you can see it uses a default executor. So it is not using your main thread. So this is a behavior when you are using dispatcher.unconfined. So yeah, we have pretty much discussed all of the dispatchers that we have, and also we have discussed the use cases, when to use which. Now I'm going to show you one more builder, which is WithContext. Just control click on it. Again we have to pass code in context. So basically using WithContext you can very easily switch threads within your coroutine builder. So by default I'm using a dispatcher.unconfined. That means it uses main thread. And let's say I want to perform some operation which will take a lot of time. Let's say I want to perform some kind of network request call. Now network request call is something which is heavily optimized for dispatcher.io. So let's say I want to just switch the thread from main to dispatcher.io or io thread. So for that you can use WithContext, as it is used to switch between thread. Well, WithContext will also provide you the return type, which is type T. So you can mention the type and it will return you the type once the execution is completed from your function. So it's a suspendable extended function over coroutine scope. Now I want to use some delay of 1 second and I want to print the thread name. So I'm using here WithContext first, and at the end I'm using thread.current thread and its name, and at the end I want to return few information, let's say 4. So this is my information that I want after the execution, and I will call this first, and at the end I am going to print this WithContext 2, and at the end I want to just use my first. Okay, so execute it. So we have first main, this is coming from here. Then we have WithContext first default dispatcher worker 1. That means this WithContext uses dispatcher default worker 1, or you can say some background thread. After the 1 second of delay, it will simply print the 4 that we are receiving from this function and printing over here. So we have first main, then the next print statement is coming from here. And if you check the thread name, you will see default dispatcher worker 1. And lastly we have WithContext 2. WithContext 2 is a string, and lastly we have the value, which is 4. This is coming from WithContext coroutine builder. Well, this is all about dispatchers. Dispatcher is usually used when you want to switch between threads. We have four different kind of dispatcher: dispatcher.io, main, unconfined, and default. And we have discussed pretty much each of them very briefly. Now we are going to discuss one of the most important thing in Kotlin coroutine, which is job. So let's say you want to execute a piece of code using Kotlin coroutine. Now this particular code is not executed instantly. Instead, it is inserted into a queue. Now in this queue we have this job variable, and this job will eventually provide you information about your Kotlin coroutine. What is job? Well, job is nothing but it is a handle for our coroutine. It has a very few fields and functions, but it will provide you a lot of extensibility. So let's see what are the extensibility it will provide us. So we have a main function. Return type is unit. I'm using here not run. I'm using a run blocking. Cool. So in this run blocking, I want to create a job. Well, job is nothing but a coroutine. So when you use launch coroutine builder, eventually the return type of launch is a job. If you want to see it, just control click on this launch. There we go. This is job. Nice. Come back to our main activity. I want to use here a repeat loop. In this we have print statement. This is the loop number, and also I want to introduce delay of 300 milliseconds. Nice. So we have this job, and I want this job started lazily. So coroutine start is lazy. So this particular job is not executed until and unless you will start it manually. So how do we start it? Well, we have job.start, and also we have a lot of functions with job. Join, start, cancel, invoke on completion, is active, children, is cancelled. So we will discuss everything one by one. So let's begin with start. So what it will do? Well, it will simply start our code in execution. And lastly, I'm gonna print this is done. Nice. So when I execute it, you will see this is done. This is 0, 1, 2, 3. Right, because this block will take some time for their execution. That's the reason we will see this is done first, and after that we will see all of these print statements that we have. Now what will happen if I just use join and execute it? You will see the behavior. This is 0, 1, 2, 3, and this is done. Because join is a suspendable function, what it will do? It will complete all of your execution that you have been mentioned within your Kotlin coroutine, and once it's done, then it will start the execution of our next line. And this is the reason why we are seeing here 0, 1, 2, 3, and after this is done. Okay, so this is the main difference between start and join. So if you want to wait until and unless your execution is not completed, you are not going to execute the next line, you will use join. Otherwise you can use start. Now let's say I want to cancel this job. So for that, just remove this lazy invocation. So now when you execute it, it will start the execution of your launch, or you can say your coroutine, because we are not passing the lazy invocation. Let's say I want to cancel this job. So how can we do it? Well, it's very easy. You can simply use here cancel, and it will cancel your job. So this is done. Because our job is cancelled, we are not going to see any kind of print statement that is present in our coroutine. Nice. We have one more function in here. We have invoke on completion, and it will give you the cost. If let's say your coroutine will throw any kind of exception, it will catch those exception and provide it in this invoke on completion. So if cost is not null, I want to print here the message. Otherwise I'm gonna print here this is invoke on completion. Okay, so execute it. You can see stand alone coroutine was cancelled. Nice. Standalone coroutine, because when you click on this launch, if you are not passing start is lazy, then it will use standalone coroutine instead of lazy standalone coroutine. Let's say I want to pass few message while cancelling our coroutine. So for that you can simply use here cancellation exception. This is cancel message, and now when you execute it, you will see this message will be printed over here. This is done, and this is the cancel message. Well, this print statement is present over here. So after the execution of your job, it will simply invoke this particular block with those exceptions that you might throw during the execution. You will see the nullability check, and after that you can very easily print it. This is how you can actually cancel a job. Every job that you are creating will also have certain state. So if you want to see these states, you can use job is, and we have three states: it's active, is completed, and is cancelled. Let's discuss it very briefly. So when you create a job, by default it is in the new state, and when you are not using start as coroutine context.lazy, by default it goes into an active state. Now in this active state we have two scenarios: either your job will start its execution and go towards the completing state, or it go towards the cancelling state. So in completing state, if all of your children that you have with this job has completed their execution, it is eventually become the completed state. That means execution of your job is done. Let's say one of your children will throw an exception. Now this will eventually cancel all of your job. Now in this case it goes into the cancelling state, and lastly it goes into the cancelled state. So this is the states we have under the hood. Now cancelling and completing are some internal states. You cannot take the information about those states. If you do so, it will return you information about is active or active state. So we have here three flags. Is active will return you information about the active state, is completed will return you information about the completed state, whether it is completed or not, and we have is cancelled. So it will return you information about the cancelled state, whether it is cancelled or not. So this is states we are having under the hood with jobs. Now it's a very good time to start our journey to discuss parent-child relationships in job. So for that I'm gonna remove all of this code. Well, it's very easy. I'm gonna create a variable naming job, and I'm gonna start a coroutine, or you can say a job. Now if you create one more launch within this, eventually it will become children's of our top level launch, or you can say top level job. We have another launch, we have another launch, we have another launch, we have another launch, we have another launch. So we have a lot of launch. That means this parent contains a lot of children's. Right now what will happen if I want to throw an exception from my last children's of this hierarchy, job hierarchy? What will happen? Well, in this case your parent job execution is terminated. This is because of structured concurrency. And also when you cancel this job, it is automatically cancelled all of their children's. This is also because of structured concurrency. This is how it was built. So let's see that. So first I'm gonna throw an exception, and in this exception I'm gonna print some message, and lastly I'm using job invoke on completion and check the cause, print the message. So it dot message. Right now when I execute it, you will see this cause. This is the cause message, and we are getting this exception. Cool. Now what will happen if I cancel this job? Does it also cancel all of these children's? Well, let's see. So for that I'm gonna remove this exception and use here print ln. This is child, or you can say this is last children. I'm gonna just copy this. This is, let's say, 0th, 1, 2, alright. So now I'm gonna use job cancel and join. So what is the difference between cancel and join? Well, if you just control click on it, in this we have two different functions. We have cancel and join. So first it will cancel your coroutine, and after that it waits for the confirmation whether it is completed or not. If it is completed, then only it will proceed with the next line. So this is the difference between cancel and join. Nice. So let me execute it. Okay, so you can see standalone coroutine was cancelled, and if our parent is cancelled, by default it cancel all of our children's. Due to that reason you are not going to see these print statements. So this is the first way of establishing parent child relationship. Now I'm going to show you one more way of doing this. Just create one more launch, and in this launch again I'm going to use a repeat for 4 times. I'm using here print ln. This is parent, and I just print here the loop count number. Delay of, let's say I want to introduce here delay of 300 milliseconds. So this is my parent, and now I'm gonna copy this, paste in here. This is my job 2. I want to repeat this loop for 3 times, and its duration is 100 millis. Now if you want to establish a parent child relationship between these two, what you can do, you can simply pass in a place of context, or you can say coroutine context.element this job. So now this first job will eventually become the parent of our job 2. Nice. So let me just remove it, and I want to execute it. Okay, so this is parent, this is parent, this is parent. This is because in both print statement I'm using a parent. Let's use child, and now when you execute it, you will see parent child, parent child, child child, parent parent parent. Nice. So as I said to you, when you throw any exception from this children job, eventually it stops the execution of this parent. So let's do that. Throw exception, some gibberish, and execute it. Okay, so this is parent, this is child, and after that we will see this exception because of invoke on completion print statements, and after that we have this exception message. Cool. Now I'm gonna create one more job, and this time I'm going to show you our parent job is active until and unless all of their job complete their execution. So we have here job 3, and I'm going to remove this delay, right? So job, that means this is a parent of job 2 and job 3. This is children, let's say I'm using here children 1 and I'm using here children 2. Nice. And also I want to print some information about my parent job. So how can we do this? Remove this throw because I want to just show you whether our parent is active or not. So for that I'm using println function info about parent, and in this information I'm gonna use job is active, job is completed, job is cancelled. So logically your parent job will take only few moments to complete, but your children's will surely take little more time. So now when I execute, you can see all the time we will see this parent is active is true. This is because our children is not finished their execution. Due to that reason our parent job is not completed their execution. I hope you got the point. Your parent will never stops their execution until and unless all of your children not finishes their tasks. So this is a relation between parent and child in jobs. Now within job, let's say you want to check whether this job is active or not. So you can do that thing very easily. So for that you should use here is active. So this will give you information about your job whether it is active or not. We have one more function naming ensure active. So what's the main difference between is active and ensure active? Let's say you cancelled this job but somehow it is not stopping their execution. So in this scenario you surely want to cancel this job execution. So this surety will be provided by ensure active. So every time when your loop execute or every time your coroutine execute, it will check whether this coroutine was cancelled or not. If it was cancelled, it surely throw an cancellation exception. So by doing it, it will simply stops your job or coroutine execution. But with is active, it is not the case. It simply checks whether it is active or not and simply start or stops your execution. It depends on the active state. But with ensure active, it is not the case. It is all the time checking whether it is cancelled or not. So if it was cancelled, it simply throw cancellation exception, otherwise it continue your execution. So this is the difference between is active and ensure active, and ensure active is used when you want some surety for your coroutine to be cancelled. So you can use ensure active. Lastly, we have supervisor job. Well, the main difference between normal job and supervisor job is with supervisor job, it simply digests your exception and continues their execution. So let's see with an example. So for that, I'm gonna just remove everything and I'm using here supervisor job. Also, I want a scope. So create a coroutine scope, and in this context, we can pass job and dispatcher. So for dispatchers, I'm using here dispatcher dot default. All right, so now I'm gonna create here job 1 launch, and I want to launch this thing on this scope. So scope dot launch, repeat this thing for 4 times, use here print ln. This is first job and you can mention the count. Use delay of 300 milliseconds. So this is for the job 1. I'm gonna simply copy this stuff, paste in here. This will become job 2. Well, I'm using this job here in our scope. Automatically all of this job will become the part of our supervisor job. So supervisor job act as a parent for these jobs, job 1 and job 2. Nice. So after this delay, I want to throw exception, and in this exception, job 2 throws an exception. Nice. So as I said to you, because we are using supervisor job, it simply digests your exception and continue their execution. I want to use one more job, naming job 3. Okay, so this is my third job, this is my second job. Nice. And at the end, I just want this invocation block. So now when I execute it, okay, so process finished with exit code 0. So let's see why it is happening. Okay, so I forgot to manually start this job. So use job.join and now execute it. Okay, so you can see this is first job 0, this is third job, second job, whatever. At the end, you can see job 2 throws an exception, but after that, it's still continuing our execution. So this is a difference between a normal job and supervisor job. Supervisor job internally uses by our view model scope. I hope you got the point, and also I hope you got everything which is related to job. We have discussed a lot of things. We have discussed about the job, we have discussed about its state, we have discussed about the parent-child relations that we have with jobs. I want to tell you one more thing which is a bit interesting. So for that, let me just remove these jobs, and also I want to remove these things, remove this scope, and also remove this scope. Nice. So let's say in this job 1, I'm using start as coroutine start dot lazy, right? And I want to make this job 1 as parent of my job 2. Nice. So logically, until and unless you will not trigger this job 1 manually, it will never start execution. But when you execute it, you can see it starts its job. Well, this is somehow it's related to the behavior, because our children, sometimes our children is also able to execute the execution of our parent. Now in this case, our children will force the parent to start their execution. This is a reason why we are seeing these things. So basically it starts the execution of our parent, and if I remove this, you will see all of the parent statements. Cool. Now we are going to discuss one of the most important thing in KOTLIN Coroutine, which is coroutine scope. We have various types of coroutine scope in our Android or in our KOTLIN Coroutine. We have global scope, we have main scope, lifecycle scope, and view model scope. A coroutine scope is a context that manages our coroutine's lifecycle. All the coroutine that you were launching using a scope, it gets cancelled when the scope is cancelled. So let's discuss all of the scopes that we have. So we have here main function, and in this main function I'm gonna use return type unit, run blocking, and in this run blocking I'm using global scope. So global scope launch. The life cycle of your global scope is tied up with your application life cycle. And in this global scope, I just want to produce delay of 200 millisecond, and just after this I'm using print ln. This is last line, and at the end I'm gonna sleep my thread for 1 second in order to complete this execution. So execute it. Here you can see this is a last line. So global scope lifecycle is totally tied up with your application lifecycle. It lives till your application live, and once the application is destroyed, eventually all of the core routine that you were launching using global scope is automatically got cancelled. So this is what global scope is, and it is not highly recommended because sometimes it leaves memory and it encourages the memory leak. So due to that reason, you will not see global scope in most of the projects. So this is what we have with global scope. Now let's discuss main scope. So let's say you want to perform some kind of operation which is related to user interface. So this kind of operation you can perform using main scope, because main scope is eventually uses main thread, and if you are using main thread, you can touch UI and you can perform task with your user interface. So for that, I'm gonna use that main scope in my main activity because my activity contains user interfaces. So I'm using a delegation Coroutine scope by main scope. Now you can use this main scope within your on create. Just use here launch. Now this launch uses main scope, and if you want to cancel all of your coroutine, so for that you can use on destroy, and in this on destroy you can use cancel. So it automatically cancel all of the coroutine that you are creating using this main scope. So let me just import it properly. There we go. This is what we have. So if you want to perform any kind of UI operation, you can use this main scope. Let's discuss lifecycle scope. So that lifecycle scope is automatically coming within our activity, and it is coming from our Android X.activity package or dependency. Remove it. Next we have lifecycle scope. So this lifecycle is totally tied up with our activity lifecycle. So when your activity got destroyed, all of the coroutine that you were launching using this lifecycle scope is also got destroyed or cancelled. Similarly, for fragments, we have lifecycle scope, and that lifecycle scope is tied up with fragment lifecycle. So this is the difference between lifecycle scope in activity and lifecycle scope in fragment. So if you want to perform any kind of UI operation, you can go with main scope, and if you want to perform anything which is not related to UI, you can go with lifecycle scope. By the way, if you want to perform some operation and after that you want to update your user interface, you can use WithContext, switch the thread, and then update your user interface. So it's totally up to you. So we saw global scope, we saw main scope, we saw lifecycle scope. Now we are going to discuss about view model scope. Well, view model scope is something which is related to our view model. Its lifecycle is totally tied up with our view model lifecycle. So let me just show you. So for that, I'm gonna create here a class, my view model, and extend this thing with view model. And in this, I'm using init block. We have view model scope dot launch. So this view model scope is totally tied up with our view model lifecycle, and once our view model got destroyed, all of the coroutine that you were launching using this view model scope is automatically got destroyed. So this is what we have with coroutine scope. So we saw global scope, main scope, lifecycle scope, and view model scope. Now we are going to discuss one more, which is a custom coroutine scope. Let's say I want to create a custom coroutine scope. So for that, let me just comment this thing out. I'm gonna create a job, import this. Now I want to create a scope. So you can use custom coroutine scope. In this we have to pass a context. So coroutine context contains few elements like job, dispatchers. So you can pass your job plus the dispatcher, I mean the thread which you want to use this scope. So we have here dispatcher. Let's say I want to use here main. So you can perform your operation, and after that you can simply use your scope dot cancel to cancel all of your coroutine that you are launching using this scope. So we have 5 different types of Kotlin scope and we saw one by one. So that's it for this video. I think you got the Kotlin scope concept and also you got everything that we have with this Kotlin scope, like global scope, main scope, lifecycle scope, view model scope, and Kotlin scope, which is a custom one. We will meet in our next video where we will discuss something new about Kotlin coroutine. Till that, goodbye.